Hello, I'm Mr. Tapia. In this video we'll cover balancing chemical equations, and this will be part 4. So I chose in this exercise a little bit more difficult one, primarily for the difficulty level. I'm going to go ahead and use the method I taught in video 2, or in part 2, because I feel that if you really don't understand chemical equations, or balancing chemical equations, that way is probably the best way for you to learn. So let's get started. As you can see from the equation here, we have a pretty long and kind of seemingly complicated chemical equation. But like all chemical equations, we're going to start in the same exact place. Basically, we have to end up with, at the end, what we have in the beginning. So the first thing we need to do is take inventory. As you can see from the first side, or the left side, which is the product side, we can go ahead and write out what we have. And so we have aluminum, bromine, we have potassium, we have a sulfate here, so SO4. We're going to go to the other side. We have potassium, we have bromine, which go together, and we have aluminum and a sulfate as well. And so I'm going to go ahead and underline these. Alright, so as you can see from the aluminum has no numbers next to it, so it moves in sets of 1. So we just basically 1, 2, 3, 4, 5. Okay, and I think 8 should do it. As you can see from bromine, we move in sets of 3, so we have 3, 6, 9, 12, 15, 18, 21, I believe, and 24. And as you can see from potassium, we have the 2, so we move in sets of 2, so 2, 4, 6, 8, 10, 12, and 14. And as you can see from sulfate, so sulfate is a molecule, not an element, and that is really important to understand. And as you can see, we have a sulfate here molecule, right, and a sulfate here molecule. So if the molecule is represented on both sides of the equation, we can forget breaking it apart and just keep it as 1. So SO4 is 1, so this S, let's see, this SO4, which is what this is, okay, it's represented on this side and on the left side and on the right side. And so because it's just one molecule here, we can go ahead and move it in sets of 1 to make the balancing part easier. So we go to the other side, the reactant side, and we have potassium. And as you can see, it has no numbers next to it, and so of course it goes in sets of 1. Bromine also, like it, has no numbers next to it, or nothing next to it, and so it moves also in sets of 1. And as you can see on this side, we have aluminum and we have a sulfate. Okay, so aluminum, it has a 2 next to it, and so it moves in sets of 2. 2, 4, 6, 8, 10, 12, and I'll put one more, 14. Okay, now the sulfate molecule has a 3 next to it, and so this 3 is saying there are 3 molecules of sulfate, and so we're going to go ahead and plug it in, and basically this 3 tells us that this molecule here moves in sets of 3. So we have 3, 6, 9, 12, 15, 18, and 21. Okay, so where do we start? That always seems to be the most common question. And of course, I like to start at the biggest number or the biggest molecule. And as you can see, this molecule here on this side looks like it's the biggest. And so I'm going to start there. So the first thing we're going to do is select the first possible selection. Okay, so can this exist on the other side? So first we need a place on the other side, this side over here, the product side, that matches this. So is there a 3 sulfate? Well, there's one right here, and so we can select this one. Is there a 2 aluminum, or 2 aluminum atoms on this side? Well, there is. Okay, and so far so good. Now let's go to this side. So we have bromine. So is there a 6 bromine. Okay, so we balance this one out. Is there a 6 bromine? Well, as you looked right here, there is a 6 bromine. So, does it all line up? Well, let's see. We have 2 aluminums. We have 2 aluminums. We have 6 potassiums, 6 potassiums. We have 6 bromines, and we have 6 bromines. And we have 3 sulfates and 3 sulfates. So this is a fully balanced chemical equation. To get the numbers for these little empty spaces here, all you have to do is count. Let me get a different color for you. Alright, so how many spaces down do we go to get these answers? Well, we went 1, 2, and so because we went 2 spaces down, this would be a 2. We went 1, 2, 3, and because we went 3 spaces down, this would be a 3. This one would be 1, 2, 3, 4, 5, 6. So 6 spaces down, and this one is 1 spaces down. Oh, I didn't write this one down. And that is how you balance chemical equations. The way that you know that you're doing it correctly is when you have prime numbers inside the chemical equation. I hope you enjoyed my video. Thank you for watching.